Welcome to this Skill Builder session on correlation. This session will specifically focus on a particular type of correlation known as Pearson correlation, and we'll look at what this is and when we can use it. A correlation describes an association between variables. What that means is when one variable changes, so does the other. It's important to be aware that correlation shows covariation rather than a direct causal link. Some examples to explain what I mean by this include things like ice cream sales and shark attacks. So as ice cream sales increase, so does the number of shark attacks, but this does not mean that ice cream sales cause shark attacks. Another example is time spent in shops and temperature. People tend to spend more time in shops when the weather is cold. So time in shops increases as temperature decreases, but this doesn't mean that shopping causes temperature. The Pearson correlation is the most widely used correlation coefficient. The coefficient is a number between -1 and 1 that measures the strength and direction of the relationship between variables. So this means that a correlation coefficient of 1 would be a perfect positive correlation. 0 would mean that there is no correlation between the variables, and a coefficient of -1 would mean that there's a perfect negative correlation. With a positive correlation, when one variable changes, the other variable changes in the same direction. With a negative correlation, when one variable changes, the other changes in the opposite direction. So as you can see in these examples, when the relationship is perfect, so when the coefficient is exactly 1 or -1, the data points fall perfectly on the line of best fit. But it's unlikely that you'd see such a perfect relationship between variables, so we need to consider the different strengths of correlation coefficients. When the coefficient is greater than positive or negative 0.5, we can say that there is a strong relationship. As you can see, the data points are close to the line, but they don't fit perfectly. A coefficient between 0 and 0.3 is considered a weak relationship, and as you can see, the points are farther away from the line of best fit. If you'd like to use Pearson correlation to test your hypothesis, there are a number of assumptions or requirements that your data must meet. First of all, you must have continuous variables. You also need related pairs. This means that each individual or observation provides a score on both variable x and y, so both pieces of information need to be from the same individual or object. You need independence of observations, meaning that the observations that make up your data must be independent of one another. So each observation or measurement shouldn't be influenced by any other observation or measurement. Homoscedasticity is assumed. This means that there must be a roughly equal spread of data points around the line of best fit for variable x and y, and Pearson correlation assumes normal distribution. A separate skill builder covers normal distribution if you'd like to learn more about this. If your data fail to meet these assumptions, then there might be issues with the validity and interpretation of the Pearson correlation. For example, the results might be biased or misleading. If your data do fail to meet these assumptions, you might want to consider using an alternative statistical test. For example, if your data are ordinal, not normally distributed, or if you have outliers, then another common way to investigate the relationship between variables is this Spearman's row correlation. For guidance on the broader range of stats tests, please go to the Skills for Academic Success website at kent.ac.uk/SAS, where you can view more of our numeracy and statistics videos. You can also book a one-to-one appointment with one of the SAS team.